everyone. Let's start our next topic of electricity, that advantages of parallel circuit over series circuit. Children, we had done in the previous two videos, we had talked about the equivalent resistance in case of series circuit and in case of parallel circuit. In series circuit, the equivalent resistance is equal to the sum of the individual resistances. That means in a circuit, if there are 2, 3, 4 or n number of resistances, then the whole circuit will have the resistance which is equal to the sum of these individual resistances. And in case of parallel circuit, the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistances. It means if there are, if we do the calculation, we come to know the equivalent resistance in case of series circuit is more than that of the parallel circuit. So now I'll explain you the advantages of parallel circuit over series circuit. Resistance in parallel circuit is decreased. The first point which I told you, in case of series circuit, equivalent resistance is the sum of the individual resistances. Suppose there are three resistance, 2 ohm, 3 ohm and 4 ohm. Then equivalent resistances will be equal to 2 plus 3 plus 4, that is equals to 9 ohm. And same thing if we do for, this is for series. If we do the same thing, apply the same, we take the same, but we want to find out the equivalent resistance in case of parallel circuit. That will be equal to 1 upon 2 plus 1 upon 3 plus 1 upon 4. So what will be the, like 2, 3, 4. Let me take the LCM. That is 12. 12, 6 plus 4 plus 3, that is equals to 13 upon 12, that is equals to 1 point something. So you can say 1 point dash something here. 1 point something ohm. Now you see here the resistance was 9 ohm when they were connected in series, and when they are connected in parallel, 9 and 1 point something. You see the comparison. Resistance in parallel circuit is less or decreased. It is less than that of series circuit. That means to the flow of current, the resistance will be less in case of parallel circuit than that of series circuit. Second point, different appliances will have there will be different switches to on and off different appliances in case of parallel. But in case of series circuit, all the appliances will be connected through one switch. There will be, like in case of, you can talk, I can give you the example of fairy lights. The lights which we use at the time of decoration, for decoration at the time of Diwali. For Diwali time we use those lights. Those decoration lights, we have only one switch to put on all those lights. From once go, you can put on at a time more than 100 bulbs. But if these 100 bulbs are connected in parallel, these 100 will have 100 switches to put them on and off. This is another advantage of parallel. Suppose if you want to put on the fan of your room, there are one fan, one tube light and one cooler in your room, and you want to put only one at a time. You will use one single switch given for light if you want to put on the light. If you want to put on the fan, you will use another switch. If you want to put on cooler, you will use another switch. But what will happen if all these three appliances are connected in series? If all these three appliances are connected in series, then you will have only one switch. Whether you need to put on all the appliances at a time or not, it will not depend on your wish. If you want to put on one appliance at a time, that means you need to have a parallel circuit, because in parallel circuit different appliances have different switches to put on them or to off them. Third point, different appliances with highly varying current requirements. Suppose it means different appliances with highly varying current requirements. You want to put on a fan and you want to put on a oven. Put on an oven, or you can say geyser. Do these two appliances, an oven and a fan, do they need same amount of current? No, I don't think so. Fan does not, but the voltage in parallel is same. Voltage does not get divided. We need 220 volt. We need 220 volt voltage to run these appliances, but the amount of current you needed to run these appliances is different. Fan does not need that amount of current as an oven requires. That means different appliances have highly varying current requirements. Fan does not need that high current as that of an oven or as that of a geyser. So different appliances with highly varying current requirement. As you all know, the current gets divided in parallel. So it is according to our wish whether with the low amount of current supply in the line where there is a low amount of current supply, whether we want to connect a fan or we want to connect a tube light. And from the line from where the high amount of current is passing, what do we want to connect over there? It will be according to our wish. Children, this is very important question and generally asked question in the board exam also, to write the advantages of parallel circuit over series circuit. This is all about advantages of parallel circuit over series circuit. Now, I just want to give a small recap of the previous equations which we have discussed in this lesson. First equation we had talked about was how to calculate the charge. We can calculate Q is the charge. How do we calculate it? We can calculate the charge by the equation N into E. What is N? N is the number of electrons. E is the charge on one electron. With the help of this equation, we can find out the amount of charge. Second, I symbolizes current. If I want to find out the amount of current, if I am given the charge and I am given the time, I can very well find out the value of I, that is I is equal to Q upon T, or Q is equal to I into T. So for Q I can use this equation also and I can use this equation also. Third, how to find out the potential difference. According to the definition of the potential difference, it is the amount of the work done to move a unit positive charge from one point to another in an electric field. So V, that is volt, that is the potential difference, is equal to W upon Q. This was the third equation we had talked about. Then we had talked about Ohm's law. According to Ohm's law, when we calculated, we came to know V, that is potential difference, is equal to I into R, where I is the current and R is the resistance offered by the conductor. Then we had done how to calculate the equivalent resistance when a number of resistances are connected in series. So here is the formula. Equivalent resistance is equal to the sum of the individual resistances, R1 plus R2 plus R3, n number. N may be the number. N means it can be any number. It can be 3, 4, 5, 6, 7, 8, 9, 10 like that. And in case of parallel circuit, how we find out the equivalent resistance? In case of parallel circuit, the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistances. The reciprocal of the sum of the individual resistances. Then we had talked about the factors on which the resistance of a conductor depends. Factors, we had talked about the length of the conductor, we had talked about area of the cross section, then we had talked about the you can say temperature, and we had also talked about the material of which the conductor is made up of. Children, that's all for chapter till now. Next time we'll talk about heating effect of electric current.